Hello, welcome. Let's try to solve another lead code problem. 3113. Find the number of subarrays where boundary elements are maximum. Let's try to understand the problem. So we are giving an array positive integer nums. Return the number of subarrays. So subarray is contiguous, non-empty sequence of elements within an array. So for example, 1, 1, 4, 1, 4, 3, it is the subarrays. Yeah, where the first and the last elements of the subarrays are equal. So we're gonna return the number of subarrays where the first and the last element is equal to the largest element in the subarray. So for example, this number 3, the first, last equal, and the largest is also 3. So we're gonna count it as 1. So in total, there are 5 single numbers, and also there is a tuple with number 3 and 3. It also meets the conditions because the largest and the left and right side it is 3, and the largest element is also 3. So we're gonna count it as 1. So there are 6. And for this example, there are 6 because 3, 3, 3, 3 single ones, this 3 and this 3, and those 2 3, and 3 3s, it's gonna be 6. And this one, because there's only one number, so we're gonna return 1. So how can we solve the problem? Because we are going to check some patterns. So for example, from the left side and the right side is equal. So what is in the middle? It may be equal, it is okay. Or maybe it is smaller, it is also okay. But can it be bigger? It cannot be bigger. Yeah. So this means the problem, it seems like a monotonic decreasing stack. It's gonna be smaller and smaller and smaller. Yeah. So what if we find an element bigger? Maybe this one. So this is 3. Maybe this is also 3. So we're gonna pop it out, pop out, pop out, and pop out. And if we find some numbers equal, so for example, this is 3 equal to this 3, so we're gonna count it as one of the result. We're gonna put the result plus 1. Yeah. So my idea is that from the beginning, I'm gonna prepare a hash table. So for each of the index, like from 0 to n-1, I'm gonna have a result of 1. So for the last one, maybe n-1, I will have a count of 1. Because I will return the sum of all those values inside of the dictionary. Yeah, because if I didn't, so the sum of them will be 5. Because each number, each index, I gonna get the index as my k for the hash table. So I gonna return 5. But now I want to use a monotonic stack to accumulate some numbers at some indexes. So for example, this is index 2 and 3. So for index 2, it is 1. Index 3, it is 1. Yeah. So what are you gonna do? I'm gonna prepare a monotonic stack. So 1, 4. It is increasing, so I'm gonna pop out 1. I'm gonna keep a 4. So this is 4. I want to keep it a monotonic decreasing stack. So for the next one, it is 3. So I put it here. And the next one, it is 3. Yeah, it is not decreasing because it is equal. So I want to pop it out. So while I pop out this number 3, so it means I find one more result. Before, it is always to be 1. Now, I find one more result. So this result for this 3 equals to 3. I want to, this is index 2 and this is index 3. I want to put the result inside the index 3. Because for this number, I'm gonna pop it out. I will not use it anymore. Yeah, because this is monotonic decreasing. So I want to put the index with index I, so this is I. For this index is 3, I'm gonna plus 1, it's gonna be 2. And then I'm gonna pop out another number 4. Currently, what's left behind is only 3, and then I put 2 inside. So my result is the sum of them, it's 1 plus 2, and plus all other ones, it's gonna be 6. So this is gonna be the final result. Yeah, so this type of method is a monotonic stack with dynamic programming. Because we accumulated all those values. Actually, this is similar like the dynamic programming. Yeah. Now let me just start coding. So I'm gonna prepare a hash table. D is gonna be I to 1 for I in range length of nums. So for each of the index, I gonna call it as 1, because finally I'm gonna return a sum of d dot values. Now I want to use monotonic stack, and basically it is a monotonic decreasing stack. So for ix in enumerate nums, while stack and my value, because it is monotonic decreasing, so I would to check more than and equal, because if it is equal, I would to accumulate the result. So if x is more than and equal to nums stack minus 1, I would to pop out the index. So in J would be stack dot pop. Yeah, if I pop it out, I have to check if this value equals or not. If nums J, I popped out the value equal to my current value, it is nums I. It means I find one more result. I want to put it inside my result. Basically, it is my hash table. So I want to put it inside the di or dj. Because I popped out this j, it means next time I will not use it. So I have to accumulate it to di, because for the next time I can still use it. If I pop out this dj, it means for the next number I will get something wrong. Yeah, I have to, because I will not use this number anymore, but the result I need to put it inside the di. So di should plus equal to dj. So this is why it seems like dynamic programming. Yeah, because dj is always start the previous result. Now I want to put it inside the di. Yeah, and then if we go out of the loop, we're gonna use stack append the index I. Yeah, and now we can return some of d dot values. As you can see, there's not so many lines of code, but it's really difficult to write. Yeah, let me check. Stack is not defined. Yeah, I need to define a stack. It's gonna be an empty stack. Yeah, as you can see, it works. Now let me submit it. And the time complexity is O(n), because for the hash table, this is O(n), and monotonic stack, this is O(n). As you can see, it's pretty fast. So what I mean is that if I put dj plus equal to di, I will get something wrong, because this index is j. If I put it the value inside the di, put my current value inside the dj, yeah, basically I accumulated 1, but for the next time I popped out this number. Yeah, so this means I popped out this number. For the next time I cannot use it anymore because I popped it out. Let's just try to run it to check. Yeah, this is for the second example. As you can see, for the second example we got a 5. Yeah, so this is because while we accumulated the value, so for example, let's just calculate it. Yeah, so we have 3, 3, 3. Let's just check. So we have 3, 3, 3. So what are we gonna do? First of all, we're gonna check this is 3 and this is 3. So because they are equal, so this is my j is my index. It is 0, so I'm gonna pop it out. Yeah, but I'm gonna accumulate for the hash table. For the 0, I'm gonna accumulate it to 2. Yeah, but what did I do? I've already popped out this is 3. Yeah, so for the next time, while I'm comparing this is 3 and this is 3, actually I'm checking the index 1, but inside the index 1 it is 1. So for this number, the index 2 should plus 1. It is so for the index 2, it is 2. So what do we get? We get a 2, 1, 2. Actually, it is not right. It should be 2, 1, 3. Yeah, this is why we should use the dj plus equal to di should plus equal to dj. Yeah, let's just check what is inside the dictionary, and you will see what happens. Really. Yeah. You see, for 0 it is a 2. For 1 it is a 2. For 2 it is 1. Yeah. So for 1. Because this dj plus equal to di, so for 1 it is a 2, but for 2 it is a 1. It means it is not right. Yeah, because we didn't calculate it right. Basically, we want to accumulate the value. So what if we use di plus equal to dj, and the strange thing happens? Let's just recalculate it. So from the beginning, 0, 1, 1, 1, and 2, 1. Now we have 3, 3. So we're going to compare the first one and the second one, 3 and 3. So if they are equal, I'm going to accumulate it to the larger index. It is di, so my current index. So it's going to be 2, right? Yeah. And now, what I popped out this 3. It is index 0. It is okay because it is just a number 1. It is not 2. Yeah, so it means this is okay. So for the next one, while I'm comparing this 3 and this 3, so this 3 it is index 2, and this index 1. So I want to put the number dj, this 2, plus 2 equal to di. So here gonna be 3. So the final result gonna be 1 plus 2 plus 3. It's gonna be 6. Yeah. So what we need to take care? We just need to take care the final result should be okay. And basically, this is the dynamic programming part. So if you basically think about this is a monotonic stack problem, maybe this is gonna be easier. Yeah, even you did something wrong, maybe you can correct it. Yeah, now let's check what is inside the dictionary. It is 1, 2, and 3 for the second example. Yeah, as you can see, 1, 2, and 3. This means our calculation is right. Now let me just submit it. Yeah, as you can see, it works. Thank you for watching. See you next.